In this episode of Finno-Ugric Machining, it will be a parting blade. As it happened, I succeeded in destroying my parting tool by it grabbed really hard and then it just bent the tool holder, the carbide holder, and it's history. It's hardened steel, and when it bends, you cannot bend it back. So I decided that maybe that's those carbide things are not my way. In this case, I decided to go into high-speed steel. This is a high-speed steel blade, which is a little bit under 2 millimeters wide, which is actually really good. It's not that carbide tool was like 3 millimeters. Now this is 2. There is a problem with that one. I will show it next. What is the problem with that one? We can overcome that. Then we need to make a holder for it. I'm going to use this piece of material, which is Uddeholm Sverker 21. This is a very good quality tool steel, and I'm pretty sure it will become a very good holder if I just can do it. This could be heat treated, but it's very good material as it is already. So, Okay, but first let's see what is wrong with this blade and how can I fix it. Okay, now this is the parting blade I'm going to use here now. It is about 2 millimeter wide, and there are the measurements. You probably can read them there. It's high-speed steel blade. If you look at the profile, then you can see that the underside is tilted. This first of all, it's tapered so that it's wider here and narrower here, which is okay when you part with it. So the top side is wider, so there is clearance on the sides. Okay. Then this here is tilted that way a little bit, and the top side, that's just my opinion, but it should be like level, and in this case it ain't. It's round, and it's round the wrong way. I wouldn't mind if it would be convex, concave. Concave. Yeah, this is because it's a cave, it's concave. If it would be concave on the top, that would be actually really good. But in this case, it isn't. It's convex. And, I don't know what the idea here was, but, actually what I will do, I will grind it straight, the top side of this one. Then we are there. That's it. And then this is the piece of Sverker 21. This is really good quality tool steel, and I need to take something off from it. I didn't have a more suitable piece there on my stock, but this is okay. So that will be modified to take this, and there you go. I actually found a smaller piece of material. I have been milling it smaller and straight. This is now the last side, and the target dimension is 18 millimeters. This sprays hot chips everywhere, so I am wearing safety goggles. Maybe you should too, just to be in the safe side. This is a metric starred edge finder. The diameter of the touch element is 6 millimeters. I am using it to locate the spindle over the edge of the workpiece. Well, it will kick to the side when the touch element touches the edge of the workpiece. After the edge has been found, I move the spindle half of the touch element diameter towards the workpiece. Then I additionally move the spindle half of the width of the workpiece to get the spindle over the center of the workpiece. Now it is the time to change over to a real cutting tool. I am using a 10 mm carbide end mill which conveniently goes to the same collet as the starred edge finder as they have the same shank size. This milling machine does not have a spindle lock, and I had it on low gear to be able to tighten the AR collet. Now I am touching the workpiece with the end mill. After touching, I will mill a 10 mm groove on the center of the workpiece. This groove needs to be 2.6 mm deep, and I will mill it in several 0.5 mm passes. This is tool steel after all. Now the groove is 2.6 mm deep, but it is too narrow. First I measure the width of the groove using an adjustable parallel and a micrometer. Well, my 10 mm carbide end mill seems to cut a 9.9 mm groove. Next I will widen the groove by milling it wider equally on each side. The target width is 11 mm.
Okay.
This is a tiny 2.5mm carbide end. The milling head is tilted 2 degrees in order to get a geometry that traps the parting blade on this side. This end mill should be run a lot faster, but this old machine cannot run that fast. I use this dovetail cutter to create a tilted surface on the other side of the groove. The angle of this cutter is 45 degrees, so I have to tilt the milling head 60 degrees to get the required 50-degree angle. The milling head has internal indexing in 15-degree intervals, so this angle is really easy to set up correctly. Cutting this side of the groove is an iterative process. I take 0.1mm cuts and test with the blade after each cut. When I can slide the blade in, the groove is ready. Now we need to slit the workpiece partly in order to be able to squeeze the blade in the groove. There is a stinky relationship between me and my slitting saws. This time I ruined 2 of them. One exploded and the other one was a victim of my stupidity. After changing over to horizontal milling and bolting the workpiece directly to milling table, the setup was rigid enough to not to chatter too much. The cutting height is such that there will be 1 millimeter left uncut at the bottom of the workpiece. The blade fits very nicely to its place and tightens really well. As always, the height adjustment of a parting blade is really critical. I make two test cuts. One without a center hole and another with it. The cut with the center hole cuts the burr from the tailstock side as designed. The result is acceptable. There is some rubbing going on the tailstock side of the cut. I need to remedy this by tilting the blade even so slightly to create a relief on the tailstock side as well. The easiest way to tilt the blade is to cut a suitable tilt on the bottom of the blade holder.
Well, that was the parting tool. Yeah, it's a very simple thing like this. It's very compact. Let me show you something. So it is really compact.
and you can actually it uses these screws here, so then you can slide the blade, and when you tighten it in place, it tightens the blade as well. Yeah, well, the idea is not mine. It's not very original, no, but it's simple to do if you have enough patience. That's what is needed here. And the material cannot be mild steel. It bends just too easily. It must be at least this grade of tool steel. This is a Sverker 21, I believe, yeah. And I didn't heat treat it. I could, but it's okay as it is. And yeah, there was casualties also in this case. Well, and well, this exploded. And then I thought, okay, I cannot use a thin blade. I have to use the thicker one because of the material. And then I started to run this on the same slot where this exploded. Well, I should have known better. There was some high-speed steel particles buried into that metal, and it spoiled this one in a second. It doesn't cut anymore. Yeah, okay. In the next episode of Finno Ugric Machining, we are going to make 2 gears for this crafting press. Actually 4. Well, if we have the time. But yeah, and that will be in the next episode of Finno Ugric Machining. Well, have a nice time and enjoy your life. Till then, bye! Yep.